Three phase means instead of giving a single phase input, you are giving three phase input. Three phase rectifier. So far we had seen only single phase, single phase, single phase half wave, single phase full wave. In the three phase rectifier is what? So if we in three phase also we have a half wave and full wave. Remember the classifications. In three phase rectifier we also have a half wave, and we have full wave. In the half wave we have uncontrolled, controlled. Full wave also we have a controlled and uncontrolled. Controlled means we use SER, uncontrolled means we use diode. So in the half wave, for example, we connect three diodes in parallel. We know these all are anode, anode, anode. It can be SCR, it's not a matter. Both are the operation is the same. So now I connect all the cathodes together. And then I connect the load here. This is the ground. This is the resistive load. This is the D1, D2, D3. I apply, maybe here I apply plus 5 volt. And here I apply 3 volt and here apply 1 volt. You see here, I am applying plus and minus. All three diodes are forward biased. And all the cathodes are short together, or short circuited together, are connected together. And I have the load. So each diode is connected to single line phase. So this is a three phase. So all the three diodes are forward biased. Do you think all the three diodes will conduct at the same time? It's never possible. It's not possible to conduct all these three diodes, even though all three of them are forward biased. Only one diode will conduct at a time based on the magnitude of the applied voltage. So I apply 5 volt, 3 volt, 1 volt. 5 is greater than 3 and 1. So the D1 will conduct. Or I apply this one with a 0-degree phase angle. I apply this second voltage as the 120-degree phase angle. And I apply 240-degree phase angle. Then still I apply the same voltage. Let us say 0 degree with plus 5 volt, 120 degree plus 5 volt, and 240 degree plus 5 volt. Instead of applying different voltage level, I apply the same plus 5 volt in all the diodes, but phase angle is different. Then what will happen? Now it will start to conduct the plus 5 volt with 0 degree first. And then it will take phase angle with 120 degree. So it's like that. So that is how this three phase rectifier is working. So for example, here, let us say this is one, let us say this is the green line 1 or phase 1. And this one is, or let me see, this one is the red phase. This is a phase 2. And now I have one more. And this is the third phase, that is the blue phase. Okay. So each voltage, each phase has same amplitude. But remember, the phase is different. So this one is starting from 0, and this one has a 120 degree phase difference, and this one also have 120 degree phase difference. So then this diode, the first, maybe if you have this D1, D2, D3, then the first diode D1 will conduct this one, and then the D2 will conduct this one, and D3 will conduct this one. So this is the input voltage. So it means, so let us take this reference point now. So then the output, what will be the output? The diode, the first diode will conduct, then the output will be like this. And then the second diode will conduct, the output will be like this, third diode, and so on. So this is the concept of the three phase full wave, or it may be a half wave. This is a half wave. The full wave, the same principle is applied. So different combinations, maybe the D1 and the D2 will conduct this first green signal, and then the D3 and the D4 will conduct during this red cycle, and D5 and D6 will conduct during this blue cycle. So instead of single diode, there will be two diodes will help the conduction. So we know that each one have the 180 degree, and then so here we have here, so 0 degree, and let us just take in our standard example 0 to pi and 2 pi. So this is 180 degree. Pi is equal to 180 degree. If we use two diodes, then one, okay, so here we have 6 diodes, right? 360 divided by 6 diodes, so that is 60 degree. So each diode will conduct for 60 degree. So the first diode will conduct, for example, the first half cycle of the green line, the D1 and the D2 will conduct 60 and 60, 120 degree. And then the second half cycle, or the red phase, the D3 and the D4 will conduct, each one will conduct 60 degree, 60 degree. So what I want to tell you here is there is a 120 degree phase difference between each of these applied line voltage, and then these diodes will conduct based on this phase difference, and then you will get the pulsating DC at the output. And of course you have to use the filter and voltage regulator to make it as a pure DC. So this is the concept behind the full wave. Don't get confused or don't afraid of the waveform like this when you look at the three-phase full wave bridge rectifier. So if you just split them, it will be like this. The diode will conduct between certain angle to certain angle. Then if you just apply this at the output, you will get like this. And each three-phase rectifier is not really important for you as a bachelor level. The single phase is already good enough. That is what you are going to do in the lab. And one last thing, like remember here, so if I use these 3 diodes, then it produces 3 pulses in one cycle. If it produces 3 pulses or 6 pulses, then we can also call this as a 3 pulse rectifier, or 1 pulse rectifier, or 6 pulse rectifiers. So it's based on the number of diodes. So each number of diode will create 1 pulse.